Hello, I'm going to talk about how to do a quadratic regression example. You'll find these in Module 2 from section 3.4, and it's very similar to what you've seen in Module 1 with linear regression, in that you're going to be given a data set and be asked to find some kind of a model function that kind of helps to make estimates or projections or predictions about that data set. So, okay, so this particular example that we're looking at is number 3, I believe, from the homework set. And when you have a description in your data set, particularly when the years are listed as inputs, which is always the top row or the left-hand column of your data set, we often do something called realigning the input values or realigning the X values so that we don't put in the entire year, but we just put in a smaller number that kind of represents how many years that particular year is from some sort of reference year or start year. Now, when you read through the description, it's not going to probably tell you what the start year is, but in the instructions, when it asks you to find the model, pay careful attention there, because that's where it's going to give you the start year. So this one says, partially because of people from a certain country are living longer, the number with Alzheimer's disease and other dementia is projected to grow each year. The table below gives millions of citizens in the country with Alzheimer's from 2000 and projected to 2050. Complete parts A through E. Okay, so right there, it doesn't do anything. It talks about the years. It doesn't talk about a reference year. It just talks about starts at 2000 and makes projections out through 2050. However, when you look at part A, when they ask to start thinking about making a plot, a scatter plot of points that are represented about this data set, or later when it asks for the function value, you see this phrase, create a scatter plot of the data with X equal to the number of years after 2000. So that right there is very important, because they're giving you the start year or the reference year that they want you to base all the X values on. And basically, we're going to take a year, figure out how many years from the start year that year represents, and the number of years is the X value, the number of years between the year that we're looking at for a particular data point and the start year. Basically, you're going to take every year and just subtract out the reference year or the start year. So the year 2000 will have an X value of 0, because that's your start year. The year 2010 will have an X value of 10, and so on. 2030 is 30 years after the year 2000, so the X value associated will be just 30. So this is an example of where we're going to realign our X values so that we're not having to type in X values into our function of huge numbers like 2045 or 2050 or something like that. Notice they have already done something called rescaling the Y values, or scaling the Y values to represent millions. So it says the table below gives millions of citizens in the country. So that for like this last data point, it means they're projecting for the year 2050, which would be an X value of 50. The number of citizens with Alzheimer's is going to be 14.5 million. So the Y values are supposed to represent millions, and then the X values are supposed to represent years after 2000. All right, so if we go through and just pick a scatter plot, I'll go ahead and switch over and put the data into the calculator. You don't have to be able to put the scatter plot on your calculator in order to do the homework here or to do your tests. You can draw them in by hand, but notice the intervals that they give you for graphing. The first interval is about your X min and X max, and then the increment is like your X scale is the third number. But notice how they all start at 0 and go out through 50, because they have already realigned the X values to start with the year 2000 represents 0 for X. So all 4 of these choices have 0 to 50 as the X values. Okay, so it's going to end up being answer C. We can put it in our calculators, but you can tell by just looking at the data that the Y values continue to increase every time, and C is the only one of the 4 graphs where the Y values or the height of the points continues to increase. So I'm just going to go ahead and select that one, and then we'll go on to the next one. This is the big one here. All right, it says find a quadratic function that models Y, the number of millions of people. So the phrasing can either say find a regression model, find a regression function, but usually they use the word modeling in there somewhere. Sometimes you'll see something about fitting. They'll say find a quadratic curve that best fits this data set, All of those are designed to take, kind of visually what you would think of as the shape made by the scatter plot and try to fit some kind of a line or curve through that shape as much as possible. It says we're going to use 4 significant digits. Now that's different than rounding to a specific number of decimal places. Significant digits mean non-zero digits. Sometimes you'll have like a really small decimal that'll be like 0.000 and then 1, 2, 3, 4, 5. So you don't count the zeros until you hit your first non-zero digit. And then once you have your first non-zero digit, you use that digit and the 3 that follow that. That's how you get 4 significant digits. Okay. So notice that there should be 3 numbers that we report here because a quadratic function has 3 types of terms. So there'll be 3 coefficients that go with it. So now I'm going to switch over to the calculator so we can put this data in there. I went ahead and wrote these numbers down earlier. Hello there. I'll try to share the calculator as quickly as possible so we can get off my baseball cap here. Okay. So when we put data in, we go to the stats menu. And edit is always where we begin. You've done this already in module 1. So this is from some other problem. It's got list 1 represents your X values, list 2 represents your Y values. When you have something in there you want to clear out, you go to the name of the list and then you hit the clear button over underneath the arrows. And when you hit enter, it'll wipe all that out. Now, same thing for it's got the kind of values I want, but it's got too many. So I'm going to clear list 1 out as well. Okay, so remember the years were 2000, 2010, 2020, 2030, 2040, 2050, but we were supposed to realign them so that the year 2000 was the first start year. So that's where X equals 0. So it just goes up by 10s after that. So I'll just go up. It only goes up through 50 years though. So we have 6 data sets. So 0, 10, 20, 30, 40, 50. And then the rest of this was millions of people that have Alzheimer's in this country. So let me look. So the first one was 3.8. So give me a minute to type in my Y values. This was just on random example that I pulled up on my homework set. All right, let me double check because I'm always bad about making typos. So 3.8, 5.9, 6.9, 8.5, 11.6, 14.5. And you can feel free to follow along with this if you want to, but I'm just going to do this quick example. So we have these 6 data points here. Again, remember, if you pair them up, the first number is how many years after the year 2000. The second number is how many millions are projected to have Alzheimer's in that country. All right, so we have our data set entered in here. So now we're going to do what it said, which is to find a quadratic model. So I'm going to kind of go back to my main screen here. I don't think you have to do that, but from your main screen is good to start. We're going to go to stats. We don't need to edit because we already put the stuff in there, but it's a calculation. And that's where you're going to start to see your regression commands. The one we used in module 1 was the 4th one here that said linear regression. But now we're going to do a quadratic because that is what the instructions said. They said, find a quadratic. And we could see in the answer blanks that there were 3 fields for the squared term, the X term, and then the constant term. All right, so we're going to select number 5 this time. This is where you have to make a choice. You put the data in, X is list 1, Y is list 2, and then you have to decide what kind of functions shape do you want to use to kind of fit through that data set. So we've been told, so at some point we would like you to pick on your own, but for right now, we're just following the instructions. It says pick quadratic regression, where it said find a quadratic function to model. So this is why you pick number 5. So it's not always stat calc 4. That's just what we were doing in module 1. It could be stat calc 5 or cubic, quartic, logarithm is number 9, exponential is the 10th one. So we're going to do all of these before it's over with. So we'll select number 5. And then we will have it calculate. If you've got the older version of the calculator where it just says quadrag, you just hit enter here. I'm going to go down here to calculate. And these are going to be the numbers that I'm going to use to form the function. I'm going to round them to 4 significant digits. So here's what we get. All right, so it shows you on these regressions what it will always do. The very top line will show you the general form of the type of function that it's creating for you. So it shows you how to put the numbers together, and then below that, because it wants to show you as many significant digits as it can, it will break down the coefficients separately, and then you choose how you want to round them when you assemble the function. Okay, so remember our instructions said round to 4 significant digits. All right, so if you'll notice, the A value starts off with a couple of zeros after the decimal place. So it's 0.00, and then here comes your first significant digit. So the first significant digit is out in the thousandths place here. It's at 2. So the 2, 2, 1, and 4, those are 4 significant digits. Since the 4 is followed by a 2, we will not round the 4 up. I'm gonna write this down on my paper so I can turn around and put it into the homework in a minute. 0.00, and then here come my significant digits. 1, 2, 3, 4, 2, 2, 1, 4. That means times x squared, because this tells you what to do with the A. Now the next part says plus the B number times x, and since this B value is positive, I am going to write plus. Now the B value has a decimal point, and then we have a non-significant digit at 0, and then once we hit the 9, now I'm going to use the next 4 digits. Even if some of them are zeros, I'm going to use them starting from the 9. I'm going to count out 4 places: 9, 5, 5, 7. And then I look at what comes after the 7 to see if I keep the 7 or round it up to 8. Since it's followed by a 1, I would keep the 7 where it is. So the middle number rounded to 4 significant digits would be 0.0, and then 9, 5, 5, 7 are the 4 significant digits. You write those down. So that says, according to my model up there, it's the B value times x, and then plus the C value is my constant. So plus, now this last one, notice the last one, it doesn't start off with any zeros. It starts off with 4 and in the ones place. So that is a significant digit. So 4 is the first significant digit. And then we're only going to use 3 more after that because it said use 4 significant digits. So with these numbers, you read from the left to the right, the first non-zero digit that you hit begins, that's your first significant digit. And then you count however many places after that it asks for. So the 4 down here is the first significant digit. So we need 3 more after that. So it'll be 4.114. Again, we don't round the 4, the second 4, because it's followed by 2. So 4.114. Okay, so now let me go back to the homework and let me put that in to the answer so we can get to where we're making projections or predictions or whatever you want to call it with it. Okay, so report the model with 4 significant digits. So the number in front of x squared right here, this was supposed to be the A value that we got from our calculator. We rounded it to 4 significant digits is 0.002214. So 0.002214. Next was what we put in for the B value. That's what goes with X. And to 4 significant digits was 0.0 and then 9557. That was times the X. And then the constant term started right off with a significant digit. So it's 4.114. 114. Okay, so each of those has 4 significant digits. So let's check that, see what it's like. Okay, yay, we got it right. So now, is that all it asked? I'm sure there's more questions. So part C, it says graph the data and the model on the same axis and comment on the fit. Well, we already know that it's B because that was the only one that had the right scatter plot. If we were to graph these on our calculators, we would just go to where it says y equals and switch on where it says plot 1 at the top. And we would want to set our windows up like this, and then we would see these points, so we would see the curve graph right through there. Okay. Now, what we're trying to comment on about the fit, it's a pretty good fit, because even though it doesn't hit every point exactly, it kind of looks like it hits maybe the 3rd point and maybe the very last one exactly, but they're all fairly close. They're, you know, if it's a little bit low on the second point here, it's a little bit high on the 4th point. And that's kind of what you want. You want about the same distance between the points that are above and the points that are below. So it's a pretty good fit. So let's see, comment on the fit of the model, choose the correct answer below. A, the model is an excellent fit because it passes through all of the data points. Oh, maybe, I don't know if it passes through. Part B, the model is a mediocre fit because it passes close to some of the data points. I mean, that describes what a mediocre fit would look like, or passes close to, but I think it does better than that. Part C, the model is a good fit because it passes close to all of the data points. That one sounds about right to me. Part D, the model is a poor fit because it does not pass close to any of the data points. So I'm going to say C, because it doesn't look like it hits exactly, because you can see some points hit above, and just below. But it's still good for getting the gist of what's going on there. Okay, so now we start to use it just like a regular function at this point. It says, how many citizens does the model predict will have Alzheimer's disease or other dementia in 2058? Now, listen, it says, how many citizens does the model predict? So even if it asked us for a year that we already had up there in our table, it didn't say, what does the table predict? It says, what does the model predict? So I would want to take this function that I have typed out here in part B. I need to enter this into my calculator and then put in the X value associated with the year 2058. Okay, which would, I think, if you take out the 2000, the start year, it's 58 is going to be the X value. So I have to first put this function into my calculator, the one that had the 0.002214 times X squared and so on. I'm going to put that into my calculator. And once I have it in my calculator, I'm going to substitute 58 for X and have it work that out. And it just says rounded to one decimal place. Okay, so now I'm going to go back to the calculator one last time. Here, share that. Okay. So also something that it didn't say in this particular problem, but sometimes it'll say use your unrounded model to make your predictions. And so in that case, you want to use all of the decimal points. Our case, it didn't say, so I'm assuming we want to use our rounded values like what we typed in. But if you ever see an instruction that says use the unrounded model or the unrounded values to predict some sort of outcome, you want to make sure that you use all of these digits. So let me take a quick detour and show you how to do that. I'm going to do that stats calc thing again. And right here, when we get to the quadratic regression, down here under store, that's what that's for. If you want to store the most accurate version of it, which would be good for making the predictions, but it's kind of a pain in the rear to have to type in all 10 of those if you're trying to use my math lab to report an answer. So sometimes it'll have you round off what you put in to check your answer, but it'll ask you to use the more accurate, all of the decimals of the unrounded model to make your prediction. So if you're having anything like that, then you would go in and just type the Y1, the row where you would like to have it stored right here. There's more details on this in other videos, but the quickest way to get to Y1 is to hit the F4 list of functions. So you hit alpha trace, select one right there. That's going to take that model we just saw it. It's going to copy the whole, it's going to assemble it for us. It looks exactly the same here, but when we go hit Y equals, it will have put the most accurate version. It'll have the, not just the 2214, which is technically what the problem we're working for an example only asked us for that, but it'll have all the way out to the 857 times X squared and so on. So let me show you. Okay, so do you see what it's done here? It's got, oh, it even went more, it took even way more places than what it was showing us on the screen. It calculated out everything it could for that A value and then times X squared. And you could just keep going plus. We have to keep scrolling down here to see, here's the next one. That's the B value, 0.09557 is all we used in our answer, but it keeps going like another 7 or 8 decimal place times X and then plus to 4.114 and a whole bunch of numbers after that. So if you needed to be really accurate about your estimates using your model, then you use that feature where you just have it copy the whole thing and assemble it for you. So when you go to the stat calc and you pick your regression, there's that line down there that says store. So you want to put a Y1 there and it will copy it like this. Okay, but now that I've shown you how to do that, let me clear it. And I'm just going to put in the rounded values that we put in our answers earlier. So it was 0.002214 X squared. This was the 4 significant digits thing. We'll do X squared plus the next one was 0.0 and then 9557. Because those are my 4 digits, 9557 times X and then plus 4.114. Okay. So you can see that significant digits doesn't mean the same thing as the number of decimal places. This one has 5 significant digits. The one before I think had 6. This one only, or not significant digits, decimal places. So our constant term only has 3 decimal places. The middle term has 5. The front term has 6 decimal places. But what they have in common is they have 4 significant digits. So starting from the first non-zero digit, you have 4 digits combined there. All right, so this is the rounded model, rounded to 4 significant digits. So that's what I'm going to use to plug in. It asked us to calculate an estimate for the year 2058. So for 2058, I'm going to do, you can plug a number into the function through your table and other ways. I'm just going to show you how to do it using that Y1 symbol again, because you can use function notation on your calculator. We just called the function Y1. And then just like you do when you're writing it on paper, between the parentheses, you put the X value that you're interested in plugging in. And when you do it this way, rather than on the graphing screen, it doesn't matter what your graphing, the edges of your window are set up. You just plug the 58 in for the X by doing this command. And again, I got the Y1 from, it's in this list of functions that are F4. So you have to do the green alpha button, alpha trace, and then select the Y1. And once you have the Y1 on your screen, you just put your input between the parentheses. And when you hit enter, boom, there it goes. 17.104956. And I honestly can't remember what it said to round to. So I'm going to write them all down and then go back to the homework problem. 17.104956. So whatever they want us to round that to, that's how many million people they're estimating our model will estimate will have Alzheimer's and other dementias in this country in the year 2058. So let me go and we'll do one more share. Will we go back to the homework and finish it up? Let me see here. All right, so let's review. We picked the model. We could have drawn the scatter plot by hand. I'll go back on the calculator and show you how you could also put that on the calculator in a minute. But basically, it was easy to pick because our Y values are always increasing, and this was the only picture that was always increasing. All right, and then we got these numbers. This is the heart of it. If you can't do this, get these numbers out, you can't do a regression command on your calculator, you're going to miss that question on every test. And it's an important part of the course, being able to take a data set, come up with a function that kind of helps describe what's going on in the data set. So if you miss them on Module 1, if you missed the homework from 3.4, study this and try it again. Make sure you know how to do this and keep practicing because it's not going away. All right, and then the third one, we just kind of, if your curve that you get from that regression model is sort of in the ballpark of what you see happening with the individual points from the data set, then you know you've done a pretty good job of finding a good fitting model. And that's what it's kind of saying down here. So down here, how many citizens does the model predict will have Alzheimer's disease or other dementia in 2058? So 2058 is 58 years after our beginning year of 2000. So X is 58. We're going to plug 58 into the model, which we did earlier. It says round it to 1 decimal place. So what we got on the calculator was 17.104. The 17.1 is the 1 decimal place. It's followed by a 0. So we would not round up that 10th place. We would keep it 17.1. Plug that in. And then, okay, here's one more. In what year after 2000 does the model predict that 10.5 million citizens will have Alzheimer's or other dementia? Okay, so this is one of those where we kind of want to work backwards from the answer. And since we're working a lot with graphs and scatter plots, I'm not going to solve this one algebraically. You could take the function that we have here in part B and make it equal the 10.5, and then subtract the 10.5 and combine it with the 4 and get negative 5 something, and that would be your C value, quadratic formula, and all that stuff. But I'm just going to do an estimate. In what year after 2000 does the model predict? So there are so many ways to do this. I don't want to confuse by showing too many ways, but let's see what the table, share it, get back here. Let's see if my table is set up. We're looking for 10.5. So let me go to my table and see if the table is set to discount up. Okay, so my table, if you go to the table up here over the graph, so you hit the blue second function button. If it's already set up to where you can see all the numbers, that means it's already set up to automatically calculate the values in whole number increments for X, which since it says round up to the next year, I think that's all that we need. And now what I'm going to do though, it said, when are the outputs going to be 10.5 million? So I'm actually watching these Y values. I'm just going to keep scrolling down my list. I'm going to hold it down so it'll go a little faster. Boom. All right, so in here somewhere, look. scoot back up. Oh, come back up here. All right, so look in here, the Y value, when we're in the year 2035, because that's what this represents, we're at 10.17, 2036, 10.42, right? 2037 is 10.68. So it's between these, so 10.5 is between 2036 and 2037, because it's 10.5 is between these two outputs. So it said round up. So I would put in 2037 is the year. So it means at the end of 2036, we're at 10.4. So once 2037 has begun, we're going to pass from 10.4 through 10.5. And at the end of that 2037, it'll be up to 10.68. So somewhere during 2037, it hits that 10.5. Okay, so it's going to be in the year 2037 if we round up. Let me also show you another, just a quick way to graph. If we're going to graph it, whoops, I didn't reset my window, did I? It was 0 to 50. And it was 0 to, I don't know, 20, I think. Doesn't have to go up very high. So let me try this again. So there's the points and there's the picture that we saw. You can always solve these equations graphically by, I want to get on this curve and figure out kind of where, if I hit trace, when you have a plot showing, you have to hit trace and then hit the down arrow. But look at what it says down here, 7.887. I can kind of scoot around with my right arrow and it's kind of like on the table, watch my Y values until it gets to 10.5 or close. 10.2, 10.3, 10.4. That's really close, 10.51. And see, it's 36, but it's more than 36. So the answer is between 36 and 37. And it said to round up to the nearest whole year. So if it's 36 point anything, we're going to bump it up to 37. Okay, so there's another way we can tell it's 2037. And then one more quick way, if we needed it a little bit more accurately, what we could do is go down to Y2 and just type in the output that we're interested in. This is called solving by graphing. Now this is just a number, so it's going to shoot a straight line across the graph at a height of 10.5. Okay, and see right there, that's kind of where that point was earlier. We want to know what the coordinates for that point where the red line and the blue line intersect, because we already know the Y value is 10.5. Everything on the red line is 10.5. But if we can do an intersect feature, that will tell us the coordinates for that ordered pair. So let me do that. And you only have to know how to do one of these, but I thought I'll just run along. So the first curve is Y1. So I'm going to hit enter for yes. Is my second curve Y2? I'm going to enter for yes. I can just hit enter for the yes. Now look what it says down here. Y is 10.5, which we knew. So X, again, is between 36 and 37. And it said round up. So if X is 37, that corresponds to the year 2037. So that's what we would put in for our final answer there. Is it part E? Oh, I don't want to do that one. I want to do this guy. All right, so round up to the nearest year, 2037. Because there's always more than 36, so that means you're partially into the year 2037. Okay, so that's probably more than you wanted, but that gets you through kind of all the different features of how you take the data, realign the X values to a particular year. I showed you again how to go to your stats menu and hit calc and select quadratic to get these values and round them to whatever you need to. Then once you have that model, you use it just like any other function that we gave you from module 1. We put it into our calculators with the X's and everything for Y1. And then we can use it to make predictions like they give you an input, you put it into the function and it calculates the output. If they give you an output, you can look at the table or you can solve by graphing by putting that number in for Y2 and then using the intersect feature to find your X value and then correspond it to the year that it represents. All right, so I hope that's helpful. Probably way too much information, but at least it gives you everything for hopefully what you can do when you need to be doing the quadratic stuff. So I will stop this now and start uploading it.